Found this cheap LED bulb in the local dollar store, and I remembered that I'd torn down a much more expensive LED bulb earlier on, so I figured I'd grab this cheapie and just see how much cheaper it is. First of all, the lens is plastic. It says it is 9 watts, 800 lumens, 120 volts, 60 hertz, 3000 Kelvin, color temperature, so fairly, what is that? That puts it warm, I think, and 120 milliamps. By Sunbeam, which is just a rebrand made in China. Sunbeam used to be a manufacturer of household goods. If you're in Canada, your mom or grandma might have had a Sunbeam, electric mixer or clothes iron or something like that. So this first thing, take a look at it actually doing its thing. So there it is, being a light bulb. Pretty much what you'd expect. Now that does look a little bit warmer white than the cold white that I've got coming from up there. You can probably see it too. I bet you could see it better if it wasn't completely glaring on you. Something like that maybe. So yeah. But it was cheap enough, $1.25, I think, maybe $2, that I'm not too worried about tearing it down. Now, something that I haven't seen commonly in Canada, but guys like Big Clive, when they're tearing down Chinese light bulbs, they see it all the time. This center tab is not actually solder like it often is. It looks like it's that kind of tack thing. Where is my knife? Actually, this is a slightly more durable knife. Try and get underneath there. Plus I got a little bit more leverage on it. Yeah, there we go. So yeah, it's just kind of a little rivet that's jammed in there. And you can see the center pin wire. Now then, the outer contact wire is going to be crimped underneath there. And it's going to be a royal pain to get out. So I'm not going to do that. This is probably glued in there, so it's going to want a little bit of persuasion. Just to loosen the glue a little bit. Oh, okay, so we got a little bit of heat sinky aluminum down in there. That's interesting. That is, whatever's holding that in, that is almost impressive for something cheap. I'm sure it's just glue.
There we go. Now it's starting to come apart.
Okay. Wow. That's silicone. Okay. After a bit of the old ultraviolence, I managed to get that far, and my God, there's still a... Nope, missed. That silicone is pernicious. It's just not going away. Wow. Okay. I have a feeling I'm going to be doing a lot of fast forwarding in the edit of this video. Okay. Here we go. Oh, okay, so there's nothing under there except for the two wires. That was kind of a waste of effort. Now let's chop that out anyways. There we go. So that's your center contact, and that's the outer contact, aka live and neutral. Even though they've got them connected. Oh no, they do have them connected right. Live is the center pin. Neutral is the outer pin. The reason for that, I'm sure you already, most of you know. The live being the center pin. Neutral is typically in North America is supposed to be at the same potential as ground. It serves a different purpose, but it should be at 0 volts. So if you're screwing this in to a base and your fingers touch there, you shouldn't get zorped. If the outlet was wired backwards and live was out there, and you have to be touching something that's grounded with your other hand, you'd get the full 120 volts across you. So they did wire that correctly. That is the center pin, that is live. So what have we here? Capacitor, bridge diode, zooming. So what do we have? We have live and neutral, a resistor that's marked F1, so obviously fusible resistor, a bridge diode, capacitor, a couple of wee resistors, another resistor that doesn't exist, U1 chip, which is an RM9003TA from, let's see, Reactor Micro. Okay, we'll do a little bit of research on that. And then we have 16 LEDs around the outside. That's cute. So I think I'm going to take a little bit of a pause. I can almost see the traces, but I'm going to take a little bit of a pause and see if I can quickly reverse engineer this and draw it up. That's what you do when you're trying to figure these things out, right? One reverse engineering and a third of a beer later, we have a schematic. This is a fairly basic little thing. The chip is, as I mentioned before, an RM9003TA, which, according to a certain amount of Googling and a judicious use of Google Translator from Chinese, is a high voltage linear LED driver, and I cannot find a data sheet. If anybody actually can read Chinese, you might be able to follow things along better than I was able to with the translator, but it doesn't matter that much. That's linear LED driver is close enough. So, what's going on inside of this thing? Ain't that fancy. So, we have the live and neutral coming in, there and there. We have a 33 ohm fusible resistor there, marked F1. And let's get a sharper pointy here. From there, we go to a bridge rectifier. There's a normal bridge rectifier. Positive and negative come out the bottom side. Positive goes through a 560K resistor. Then there's a 200 volt 10 microfarad capacitor, this guy, across the rails. Now then, when you weren't watching, so that nobody could complain about how I did it, I powered this thing up and metered a few things. There is 150 volts DC across there. It takes a little bit of time for the capacitor to charge up, but that's what it gets up to. Okay, from there, there's just the LEDs and our magic little chip left. Oh, and this 7.5 ohm resistor, which is going from one pin of the chip to the tab of the chip. It goes from this one here up to the tab. And then the other one, okay, and the tab is connected to the negative rail. So the other one is just in series with all 16 of these LEDs. I got lazy. I just drew 6 of them and yeah. So math tells us that 16 LEDs across 150 volts is going to be 9.3 volts per LED, which means there's 3 actual LED chips inside each one of these. And when I measured it, it was closer to 8.9 something something. It's hard to see because I was rather blinded at the time. Anyway, so that's all that's going on in here. This guy is just limiting the current that runs through these so that it's not, so that we're not blowing them up. Actually, I didn't meter across that. Should I? No, I don't want to. I don't want you to guys see just how janky I did that because there will be complaints. But anyway, that's all it is. It's a fairly simple circuit. Similar to a lot of the cheap Chinese LEDs that you've seen other people tear down on YouTube, I'm sure. This guy doesn't ring any bells. It's possible that other people have run into it and I've just forgotten or haven't noticed it, but yeah, it seems to do a reasonable job, and it doesn't get too hot. I mean, the board itself gets hot with, you know, all those LEDs going on it, but and where's the, yeah, there's the base. So this would be socketed into this little lip here, so this whole aluminum base would become the heat sink, which makes sense. But yeah, it's a nicely laid out little board. Everything's labeled, which is actually kind of surprising for something that cheap. Yeah, I'm almost sad that I tore it apart, except for it was only a couple of bucks. I hope you found that interesting. Thanks for watching, as always. If you've got any comments or questions, down in the comment section below. And I guess that's it for this one. I will talk to you later.